And now let's look at a more challenging question for factors and multiples. For part A, we want to find the smallest possible value of W if it leaves a remainder of 1 when divided by 32, 50 or 81. Alright, so now to do this, we will need to find the lowest common multiple of 32, 50, 81. Then we plus 1, and that will be the value of W. Okay, do you understand? Alright, since the question asks for the smallest, means we need to find the lowest common multiple of 32, 50, 81. Then we got to add 1, and that will be the value of W. And now, in order to find the LCM of 32, 50, 81, okay, we can actually break up each number into its factors. Okay, so you can do this by doing the prime factorization. So 32 will be equals to 2 to the power of 5, 50 will be 2 times 5 squared, and 81 is equals to 3 to the power of 4. Alright, so the LCM of 32, 50, 81 will be you compare the three numbers and then you find the highest power for each of them. Alright, we can see that 2 to the power of 5 is the highest, so we put here. 3 to the power of 4 is the highest, we put here. And 5 squared is the highest, we put here. Okay, so the LCM will be this times this times this. Right, you press the calculator, you will get 64,800. Okay, so the value of W will be equals to this plus 1, right, because it leaves a remainder of 1. And the answer will be 64,801. Alright, now for part B. The HCF and LCM of 150 and K are 50 and 1050 respectively. Find the value of K. Alright, this is a pretty challenging one, so do listen carefully. Okay, so we know that one of the numbers is 150, but we do not know what is K. But however, we know that the HCF of these two numbers are 50, and the LCM of these two numbers is 1050. Okay, so from here we need to work backwards to find what is K. Okay, so to do that, let's break up all the numbers into its prime factors. Alright, so 150 is equals to 2 times 3 times 5 squared. 50 is 2 times 5 squared, and 1050 is 2 times 3 times 5 squared times 7. Okay, so once again, to do all this, you can do your prime factorization to break out all three of them. And now, this is what you do. In order to see the factors clearly, let's arrange them. Alright, we know that 150 is equals to 2 times 3 times 5 squared. We write it on the first row. We do not know what is K, so we leave a blank here. Then we draw a line. Okay, but however, we know that the HCF is equals to 50. Alright, so 50 we know that is 2 times 5 squared. Okay, you notice that 2 I put in this column, while the 5 squared I put in this column. Okay, so that's the HCF. And the LCM is 1050 is equals to 2 times 3 times 5 squared times 7. Right, based on this. Okay, now you're going to work backwards, okay? You're going to work backwards to find the missing factors over here. Alright, so how do we do that? Let's look at 2 first. Alright, the HCF is 2 and the LCM is also 2. So K must have a factor of 2. Does it make sense? Right, remember, right? For HCF means you have to spot the lower power. Alright, since the lower power is 2 to the power 1, so this one must be 2 to the power 1. And now let's look at 3. There's a 3 here, there's a 3 here. But does the HCF has a factor of 3? No, it doesn't, right? So can you put a 3 here? No, you can't, right? So there's no 3 here. Okay? Let's look at 5 square. Right, there's a 5 square and 5 square and 5 square. So obviously K must also have a 5 square here. And now for the 7. Alright, there's a 7 here. So do you think you need a 7 here? Yes, you need, right? Because for LCM, you take the higher number between the two of them. Since the LCM has 7, he also must have 7. Okay? So once again, since the HCF does not have 3, so K will not have a factor of 3. So the answer for K will be 2 times 5 squared times 7, which is equals to 350.